All right, this set of notes is going to be on pages 41 and 42, and we'll cover what we know about Pascal's triangle and probabilities. So turn to page 41 in your notes, and the title of this page is going to be 41 Probability in Pascal's Triangle. Pascal's triangle can be used to find the probability of any event that has two outcomes in a single trial. So for example, the event could be heads or tails, or when we're choosing to go right or left, or if something can be correct or incorrect, or if we're counting odds and evens, or if the outcomes could be yes or no. There are other examples, but these are ones that come up pretty often, and we will see these in the problems that we practice in class. When we are looking at Pascal's triangle, the first row is the probability of the null event. Let's go ahead and highlight that. That's a new word for us. A null event means that nothing happened. It's an empty set. We didn't make a choice, so we did not flip the coin. We did not choose to go right or left. We didn't roll the die, so we can't decide if they're odd or even. There's only one way for nothing to happen, which is why that first row is a 1. And the probability of that first row would be 1 out of 1, because there's only ever one way to not do anything. But after that, each following row represents the number of trials. So for example, at row 1, we flipped 1 coin. Row 2, we flipped 2 coins, and so on. So for example, if we flip a coin 3 times, then we are going to look at row 3 of Pascal's triangle. And row 3 is 1, 3, 3, 1. All right, and remember that as we were talking about Pascal's triangle, that we can say that the first term in the triangle is all of the first outcome. So as we're looking at this list, if we were thinking about heads, the first term in row 3 would mean 3 heads. Or if we were talking about right and left, the first term would be 3 rights. Okay. So let's just say, since in our example we were flipping a coin, this first term means we got 3 heads. And the second term, then we're going to consecutively go down in heads as we move over. So this would represent 2 heads and then 1 head, and the last term is going to be 0 heads. Since we were flipping a coin, our only 2 choices were heads or tails. If we got all 3 heads, we got 0 tails. So it also represents the probability of getting 0 tails. Or when we get 2 heads, then we had to have gotten 1 tail. Or if we got 1 head, we had to have gotten 2 tails. Or if we got 0 heads, we had to have gotten 3 tails. Okay. So each term in the row represents a unique outcome, like 2 heads, 1 tail is a unique outcome, and tells the number of ways to get that outcome. So there were 3 ways to get 2 heads and 1 tail. All right, let's move on to page 42. So to find the total number of outcomes for a given trial amount, we're going to add all of the terms in the row. So if we had, look back at our row 3, the total number of outcomes, we would add 1 plus 3 plus 3 plus 1, and for row 3, the total outcomes, there are 8. So let's talk a couple examples about how we can use Pascal's triangle to find some probabilities. So example 1, find the probability of getting 4 heads and 3 tails when flipping a coin. If we got 4 heads and 3 tails, we must have flipped a total of 7 times. So we are going to look at row 7, and using our triangle, row 7 is 1, 21, 35, oh, sorry about that, 1, got tucked in a 7 there, 1, 7, 21, 35, 35, 21, 7, and another 1. Okay, so if we want to figure out how we can get 4 heads, well, the first one represents all 7 heads, and then 6 heads, 5 heads, 4 heads, 3, 2, 1, and then 0. So if we wanted 4 heads and 3 tails, we're going to go and find in our list where we had 4 heads. I'm going to highlight that as well. So the probability that we're looking for is the probability of 4 heads, 3 tails, and our favorable outcomes, the ways that we can get 4 heads and 3 tails, the total ways are 35. And then in order to get our total number of outcomes, we have to add up all the terms in this row. So 1 plus 7 plus 21 plus 35 plus 35 plus 21 plus 7 plus 1, which equals 128. So there are 128 total outcomes in row 7. And if we divide 35 divided by 128, we get 0.27, or often we write probabilities as percents. So we could write that as 27%. Okay. Our second example is we want to find the probability of 5 letters being delivered randomly and 3 of them getting delivered to the correct person. So if we go back and we look at our examples, this is an example of correct or incorrect. The letter either got delivered to the correct person or it got delivered to the incorrect person. All right, so if we are delivering 5 letters, then we are looking for the probability of 3 correct and 2 incorrect. And we're going to use row 5 of our Pascal's triangle. And row 5 is 1, 5, 10, 10, 5, 1. The first term always represents all 5 of the first outcomes. So 5 correct, 4 correct, 3 correct, 2 correct, 1 correct, and 0 correct. So we are looking for 3 correctly delivered letters. So our favorable outcomes, there are 10 ways to deliver the letters to 3 people correctly. And to find our total number of outcomes, we're going to add up that whole row, and that is going to give us a total of 32. So 10 out of, oops, that should be a 2, 10 out of 32, or that decimal gives us, when we divide that, 0.31. And we could write that as 31%. Once you finish with this set of notes, go ahead and tape your Pascal's Triangle on page 42. And I would recommend that the way that you can do this so you can still see your notes and use your notes is if you put 2 small pieces of tape along the left-hand edge of your notes. And I'll go ahead and highlight where I taped. So I just put small piece of tape there and another small piece of tape there. That way I can still fold that open and see the notes that we wrote our examples on.